Chapter 9 Climate Regions and Climate Change. Section 9.1 Factors Influencing the Diversity of Climate. So we've learned how input of solar radiation influences temperature. Now we've got to look at this in a little bit of a different way. We also have to include precipitation. So what I want to do is just describe some of the factors that influence the climates that would be perceived at various locations on our planet. So we've discussed some of this. What's missing from it is the precipitation component, and what I'm going to include in this is also talk about wind patterns and storm systems, whether or not these locations are influenced by hurricanes or mid-latitude cyclones. And this will all come together in the next section where we look at climate classification. And with the Köppen climate classification system, we'll compare climates at various locations on our planet and see, for example, that the climate of coastal California is very, very similar to the climate of Italy. Anyways, so the number one factor influencing the climate at a location is latitude. And latitude influences several different things. Latitude influences the amount of insolation that is received at a location, which influences temperature. And we know that insolation input from the sun varies seasonally as we move away from the equator to higher latitudes. But latitude also influences whether a location receives precipitation. It also influences the types of winds that may occur at a location. And in terms of precipitation, we have two belts roughly of wet areas on our planet, near the tropics where we get these thunderstorms because of the intertropical convergence zone, and at the mid-latitudes where we get the mid-latitude cyclones. We have two dry zones in the subtropics. The subtropical high pressure zone creates dry conditions, lack of precipitation, lack of clouds. And then it's very dry at the tops of the planet at very, very high latitudes because of the cold weather that's there and the lack of lifting mechanisms to produce precipitation. So, as I said, we know that climates differ because of things like the intertropical convergence zone. The subtropical high pressure zone creates dry conditions. At the polar front, we get mid-latitude cyclones, and that polar front fluctuates between roughly 40 degrees and 60 degrees of latitude depending on season. And then at the tops of the planet, we get dominant high pressure systems, or sometimes known as the polar vortex, that produces very cold winter and cool, cold summers with generally a lack of precipitation. This diagram kind of illustrates the types of climates that we should expect at various locations. So, for example, near the equator, we should have warm temperatures all year long, and wet conditions, a lot of precipitation. As we move away from the true thermal equator, we get into a zone where the intertropical convergence zone can move in during the summer period and move out during the winter, and this produces wet, warm summers and dry, hot winters. At about 30 degrees south and 30 degrees north and that area around it, we generally get very little precipitation. The intertropical convergence zone doesn't move into that area very often, and likewise the polar front doesn't move into those areas. And in these areas we get all year hot and dry. So climate. So an example that would be the Sahara Desert or the Kalahari Desert, the Middle East. They're influenced by the subtropical high pressure system, which produces descending air, and precipitation has a hard time being created in descending air. It needs to be lifted above. In the mid-latitudes, we get two zones. We get at roughly about 40 degrees of latitude, like California, hot, dry summers, wet, cool winters. So in the winters, the polar front moves in and precipitation occurs because clouds are lifted over cold fronts or clouds are produced over cold fronts and warm fronts, providing precipitation during the winter months. At about 60 degrees latitude, so a little bit further north, summers are wet, and so are winters. The summers are mild, the winters are cold. And then the final zone is at the poles, and at very high latitudes we have cool, dry summers and dry, very cold winters. So some other factors that influence the climate of a location: seasonal air masses, the types of air masses that may move into an area. For example, here in Kelowna, if you take a look out today, you'll see that the mid-latitude cyclone is here. We've got moist polar air, moist maritime polar air moving in, cooler temperatures, a lot of precipitation, cloud cover. In the summer, our climate changes drastically. We're influenced by subtropical high pressure zone. It clears up and temperatures become quite high. The types of storms that might occur at a location influence its climate, whether they're thunderstorms, mid-latitude cyclones, or even hurricanes. So if you lived along the southeast coast of the United States, hurricanes occasionally influence your climate now and then. Some places are close to oceans and they receive some heat energy, so there's heat energy exchange from the oceans, or ocean currents can affect the climate of a location. There's cold currents like the California, Canary, Benguela, and Peru, which influence coastal regions in those areas, and that's shown in a graph or a map that I'm going to show in the next slide. Another factor that influences a climate of location is what its altitude is, whether it exists in a mountain range, whether it's on the wet side of the mountain range, the windward side, or the leeward side, where precipitation isn't enhanced. Precipitation is reduced. We get a rain shadow effect on the leeward side of mountains. Precipitation is enhanced on the windward side. So if you've ever been to Hope, BC, you know that they're on the windward side of a mountain range and they receive lots of precipitation. So here's our map of cold currents. We could do the same thing with warm currents, but I just want to show this. There's the California, the Canary, the Benguela, and the Peru, and then this creates dry conditions along the coasts in those areas. So from California, from California down to the Baja in Mexico, the Canary current creates dry, cooler weather along the coast of Africa, and so does the Benguela, and the Peru current produces cooler, drier conditions along the west coast of South America. This map also shows average annual precipitation for a period of roughly 16 years. And you can see where precipitation is heavy along the intertropical convergence zone and in the mid-latitudes. But notice for the continents, the center of the continents tend to be dry because it's some distance from the major source of moisture, the oceans, and on the west coast of North America, a lot of the precipitation is squeezed out of the clouds and develop because of moist air moving in from the ocean, Pacific Ocean on our west coast. And when you get into the prairies, Saskatchewan, Alberta, Manitoba, it's pretty dry. The final diagram here shows this windward, leeward side of mountains. So when warm air is moved up a mountain range, it usually produces an increase in precipitation, and that's, you can see all the trees growing on that side. And then when you go down the leeward side of the mountain, it creates dry air conditions. The adiabatic collapse rate increases the temperature of the air and reduces the relative humidity so that it's very, very dry, very, very little precipitation on the descending side of a mountain range, on the leeward side.